everyone, today we are going to continue on with activity 10 and talk about zeros of our polynomial. Now in previous lessons, we have been sometimes given our functions in an already factored form that allows us to easily identify our zeros. Today we are going to talk about using some factoring methods to find those zeros when they aren't given to us in that factoring form. So a reminder, when we are asked for a solution or a root, that's basically another way of saying a zero, and these can be real or they can be imaginary. Sometimes they will ask us for one versus the other. We also are sometimes asked or given the factors. Oftentimes that's what we're setting equal to 0 to find our ultimate zeros, or the x-intercepts that are the points on our graph. Now our x-intercepts are only the reals because these are only the ones that we see. Now they can be either irrational or they can be rational, but these are only going to be the real ones that we see on our graph. Okay. Now some examples, and notice today the instructions are asking us for the reals only to start here. The first one is notice to the fourth and second and constant power, but we're still going to treat this like an x method factoring. So what multiplies to be negative 27 adds to be negative 6. Well, that's going to be negative 9 and positive 3. So as we write that in the factored form, the only thing that actually ends up changing when we have this slightly different to the fourth squared constant is that we're going to end up having x squared minus 9 and x squared plus 3. And from here, we can set each of these two pieces equal to 0. And as we start solving, we square root, we get positive or negative 3 as two of our zeros, and then we have x squared plus 3 equals 0 again. This time, however, when we subtract over the 3, as we try to square root, we're square rooting a negative, which would result in an imaginary answer. And since the instructions are asking us only for the reals, we're actually going to kind of ignore that part for now. So our two answers this time are going to be x is positive 3 or negative 3. You should try example 2. It is similar to this one. Now number 3 is a little bit more complicated. We can start at least by taking out a GCF of both pieces, all three pieces. So we would have a 2x that can be taken out of each piece. So we have 2x squared minus 19x and then plus 42. Now this is going to be a little bit different than our last problem because we had a 1x to the fourth before. We now have a 2x squared. So a reminder, when it comes to factoring now, you're looking what multiplies to be a times c. So 84 adds to be that middle term of negative 19. And that ends up being for us negative 12 and negative 7. So on this one, we got to be careful. We have still that 2x on this outside, and then on the inside here, we have 2x squared, and this 19x is now getting broken up to be minus 12x, minus 7x, and then plus 42. And then we end up grouping each of these two pieces. So we have a 2x that can be taken out of the first group, a negative 7 that can be taken out of the second group. And then from there, we end up with our two factors of 2x minus 7 and x minus 6. Now, don't forget, there was this GCF that we took out that also is still part of this answer, because as we set each piece equal to 0, we're setting 2x equal to 0, 2x minus 7 equal to 0, and x minus 6 equal to 0, so that we end up with 0, 7 halves, and 6 as our three real solutions this time. There's one similar to that in number 4 for you to try. Down in number 5, we see a difference of squares, and reminder, we're just looking at, okay, what squared is x to the fourth, what squared is 16. And what we notice is our two values would be x squared. Squared is x to the fourth. 4 squared is 16. This is our a and this is our b. So that when we put them in their final factored form, we'd have x squared plus 4 and x squared minus 4 as our two factors. Now, as we set each piece equal to 0 this time, again, x squared plus 4 ends up resulting in us taking the square root of a negative. So this actually doesn't end up being a piece we want to use for a real solution, because again, we don't want to end up with an imaginary right now. However, x squared minus 4 equal to 0 is going to give us two zeros at positive and negative 2. This time would be our zeros. This time in our next example, we have 36 and 1. Okay, again, think about for our difference of squares, what squared is 36, x squared, what squared is 1, to work through and get your solutions. All right, down in number 7, we see 4 terms. This is oftentimes a hint to us when we have 4 terms that we want to use some grouping. So similar to our factoring method up above, we want to look at what is the GCF of the first group. We end up with 3x squared. And then 7 would be left over after we divide out the 3x squared. These have a GCF of positive 7. And again, when we divide that out, we're left with the 10x minus 7. So that 10x minus 7 is one of our factors. The other factor then is 3x squared plus 7. And as we set each piece equal to 0, we have 10x minus 7 equals 0. Add the 7, divide by 10. X is 7/10. And then over here, as we try solving, we actually, again, are getting, unfortunately, the square root of a negative, which again is going to cause us an error. So this, again, is giving us an imaginary solution. So we're only looking at x equals 7/10 as an option. All right, in our second example, again, as we look at the grouping, this time we are able to take out a 2x squared. We're left with 5x plus 2. Second one, we are able to take out a negative 5, and we're left with 5x plus 2. 5x plus 2 ends up being one of the factors, and then the second is the 2x squared minus 5. Now again, we don't want to just get in the habit of canceling out anything. We want to set each piece equal to 0 and see what we end up getting. The first is negative 2/5. The second piece, as we set that equal to 0, we end up with x squared equals 5/2. And when we square root, we're square rooting a positive this time, so plus or minus square root of 5/2. Positive and negative would both be solutions to our polynomial. Now, on the last page, we see a type of factoring that we don't often use or haven't yet so far this year, and that is going to be our sum or difference of two cubes. So similar to our difference of two squares, this time we can do a sum though as well, we want to look at, okay, what cubed is each of these values? Okay, well, in this case, 2 cubed is 8, 5x cubed is 125x cubed. So these are our a and our b values. And each time when we have a sum or difference of two cubes, the pattern is a, b, a squared, a times b, b squared. So a, b, a squared, a times b, b squared. And the signs are based off this original. So same side as the original, opposite sign of the original, always positive. I like to call this SOAP. Same as the original, opposite of the original, always positive for that plus sign there. Now what ends up happening is this piece is always going to result in imaginary solutions. This piece is always going to result for us in a real solution. In this case, if we add over the 5x and divide by 5, we get x to equal 2/5. In the next example, again, we start off looking at, okay, what cubed is x cubed? X. What cubed is 64? 4. These, again, are A and B values. So A, B, A squared, A times B, B squared. Same sign as the original. Opposite sign of the original. Always positive. Again, this results in an imaginary. And as we set x plus 4 equal to 0, we get -4 as our solution. Now, sometimes they want us to find all of the zeros, real and imaginary. So as we look at an example like number 11, again, we have 4 terms. This is a sign that we want to use some grouping. So as we start this off, we take out the GCF of group 1, take out the GCF of group 2. We have x squared plus 4 and x plus 6 as our 2 zeros. Now previously, as we said each piece equal to 0, and if we would have seen this, we would have said, whoa, 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 taking the square root of a negative, that's not great. But this time, because we want the real and the imaginary, this time what ends up happening is we get the square root of 2i, or -2i, as our 2 solutions there. And then, of course, we still need to set x plus 6 equal to 0 to get that answer of x equals -6 as well for number 11. Right? You are going to end with looking at the solutions, real and imaginary, for number 12. Make sure you list them all out. Thanks, everyone, for watching. We'll work more with these for sure in class.